Hello, everyone. Hope you can hear me loud and clear. And just giving a couple seconds as I'm seeing folks joining. Thanks for making the time to join us today. So I'll go ahead and get started as people are logging on. I'll start here with just some of the webinar logistics. Estimating I'll need no more than 45 minutes to go through the material I've prepared, leaving us about 15 minutes or so to answer questions. So please enter those questions in the question box as the webinars goes. I am Mamadou Ba, and I have the privilege of leading the HOBO product management team here at Onset. I joined Onset back in 2011, so it's been a little bit more than 10 years. Half of it I was part of the engineering design team, and a few years back I transitioned into product management. My primary focus is supporting our connected products that we'll be touching on today, serving environmental research and agricultural applications. For anyone new to Onset, we are the proud home of the HOBO data loggers, historically known as a reliable and innovative provider of data logging solution across various applications. So we've been around for 42 years now, a little bit more than 42 years. And our data loggers, remote monitoring tools, and software solution have been used around the world to support expert growers in a broad range of monitoring applications. So we pride ourselves in providing reliable, cost-effective solution to help our users. So before I actually jump in the agenda and the content I have prepared, I just thought I'd take a step back and just share why we decided to come out with this remote water level monitoring system and why now. This is a slide I actually put last minute. Just thought it would be helpful just to help set some context. So these are some of the things we've been hearing over the last couple of years or so, where a core of our user base has been searching for a remote water platform that is more manageable. They just keep continue to adding sites. Quite a few of our users have shared that it is just time consuming and costly. They're costly trips to retrieve data as they're using our transducers. And there's also this need of near real-time water level information for compliance and auditing. And especially nowadays where water is such a scarce natural resource, we even have folks referring to water as the new oil. So all of that went into us working to get this product out. I also thought I'd just share some quotes. This customer have shared with us, in the recent weeks and months where they've been letting us know that they are blind to what's going on until they have a customer visit. So these are borderline verbatim quotes. It's expensive to go to sites. We have users that have hundreds of our transducers, and then it costs them, tens of thousands to retrieve the data. And again, more importantly, people feeling that they can even be out of compliance and not knowing. So just to set the context, and then you have multiple application around agriculture and just the need to be able to optimize irrigation by measuring water level at multiple points within a farm or a site. So with that context, we are really proud to introduce to you the HOBOnet water level monitoring system as a viable solution to combat these challenges. So the agenda I have prepared today is I first wanted to give a quick overview of the HOBOnet water level sensor, then maybe take a little bit of a step back and talk about the HOBOnet wireless sensor network system in general for some of our attendees that may not be familiar with HOBOnet. What do we mean by HOBOnet? And then I'll transition to, rather than doing a demo, I thought that, going through a deployment process, because with wireless sensor network, every deployment is a bit different. So I thought I'd go through some deployment tips, consideration, things to think about, and also just share some general applications where we've seen, this product have success. And I'm just seeing a question come through. Yes, Abdul Razak, this webinar will be recorded and made available. I apologize for failing to confirm that. And then we'll make sure to leave plenty of time for Q&A. So jumping into it, overview of the HOBOnet water level sensor. So there are three components that make out the system. So we have the moat that we refer to, or the node, which essentially has the antenna and the memory, and where we do a level of edge computing. And then it comes with a connector, and this connector acts as the interface with the direct read cable. And for some of our users that are familiar with some of our product line, this is the same cable we use with some of our direct read water level. And also we're leveraging the same sensors that we've been using for now close to a decade. They're proven sensors that have worked and that have been meeting our customer needs. So we'll have various options, both from a stainless and titanium options. But the classic depth we generally offer, the 4 meter, 9 meter, 30 meter, and 76 meter depth. So essentially, it comes with certain level of flexibility. So the moat or the node, the sensor node, is common, but the users get to select the cable length they need that needs their needs. We have, I think, about 6 standard cable length, which are a bit more cost effective, and we can get them to you faster. But we do offer custom length, anywhere from probably 0.5 meter all the way to close to 500 meters or 1,500 feet. So we have all those lengths available where required. And also we have titanium options, especially for saltwater applications. So some of the key features of the sensor node itself, we have 4 logged parameters. So we measure and log water depth at the moat level, the differential pressure, water temp, and barometric pressure. So each device comes with a barometric pressure sensor integrated, and that ensure we can do the barometric compensation that is needed to have accurate data. So with this mode, you wouldn't need to pull in, I'll call it like a third-party sensor type file for barometric pressure, so you can do any type of compensation. So it is all integrated. And on the software side, we do, again, right off the bat, we do measure water depth. But if you would like to set a reference water level as a baseline, the software will allow you to do that. And depending on what type of environment you have your system deployed, you can also account for water density. And I'll expand on these 2 areas. And it comes with all the core HOBOnet capabilities, our system that we provide today, and also an area I'll expand on shortly. Some of the specs, the operating range of the sensor node is like our other nodes. We ship the node with rechargeable batteries, and that will operate from -25 degrees C to 60. And if you are in environment that are operating in lower temperature, we always recommend transitioning to lithium batteries. They're not rechargeable, but they will last you a year. So those kind of perform better in low temp environment, the lithium batteries. Transmission range, if your transceiver is at least 1.8 meter height, you'll get about 450 meters, and at about 3 meters, you get 600 feet line of sight from sensor to sensor, and I'll expand on that a little bit. And again, the higher you have that transceiver that acts as your communication path, then the longer range you'll get. Flexible on the logging rates. Again, we have the 4 channels, batteries that we ship with will last you 3 to 5 years, so that's kind of being conservative. But generally, we trickle charging those batteries, so they will last you a while. And the device, the transceiver device itself, is IP67, so it's weatherproof, as you would expect. And this is in the sub-gigahertz range, so we have multiple frequencies that we offer depending on the region where you're located. So we essentially have a frequency for North America, for Europe, and key countries in Asia. I'm just seeing a question come through. I figure I'll address it now. Are the battery replaceable? Yes, they are, but they're actually rechargeable. So technically, again, they will last you minimum 3 to 5 years. So having to change them generally doesn't come in play. But if you're using lithium batteries, if you decide to use lithium batteries rather than the rechargeable ones, those are nickel metal hydride, the ones we ship the product with, then those lithium batteries, I would expect you to replace them because they are not rechargeable. All right. So I'm seeing some great questions coming through, but I'll be touching on some of them. So that's why I haven't responded to them yet. So some minimum system requirements. So again, the sensor itself is a wireless sensor, right? So it does require what I'll call it as a hub. So we have our RX stations for users that are familiar with it. So we have 2 options. We have the RX2106 and the RX3000. So those are our classic standard station that support our wireless sensing technology. So at the minimum, you would need one of those. Then again, you would need the direct read cable and the water depth sensor. And these are actually the same one that we use on our current Bluetooth platform. So if today you are using our Bluetooth platform to do direct read water level, and you would like to transition to more of a remote solution, at that point, all you would need to do is add the sensor node, assuming again that you have the station. And then again, I'll expand more into the whole wireless sensor network. The average cost of this system is about $800, can be a little bit lower depending on the cable length. I think the sensors run about $400, but this new device itself is $300. But generally, if I use like maybe a 5-meter cable length, that's kind of standard. It's a kind of classic length that our users order. Then the cost would be about $800. So exploring the HOBOnet wireless sensor. So I'm gonna kind of zoom out a little bit and expand a little bit more on the entire ecosystem. So HOBOnet, what do we mean by HOBOnet? So HOBOnet is a sub-gigahertz wireless mesh network that we've developed internally. HOBOnet embodies a resilient long-range wireless communication protocol. It is distinguished by its ability to cover extensive area. And some of the questions that I'm getting here is, by line of sight, does it include going through forest wetland with some leaves? It does, but certainly not two deployments are the same. But the sub-gigahertz frequency range allows you to penetrate, I guess, trees and bushes effectively. So this network, employs a mesh topology, enabling our devices not only to connect directly to that central point, which is the station, but also communicate among themselves. So they all act as transceivers and allowing to relay the data from node to node. And again, they all come with rechargeable batteries that are, and there's an integrated solar panel. And the question that I'm seeing here from Chris, will the units continue to operate while charging the batteries? Yes, they will. So we have a trickle charging mechanism that's just in the background. So essentially we have a monitoring circuitry, similar kind of to BMS a bit, that is always monitoring the battery level and slowly trickle charging it. Ultimately, just needs access to sunlight to be able to do that. And as always, we strive for ease of use. So we've developed these in such a way they are really easy to mount to poles or posts. So these are kind of the pillars that I view, kind of how we've developed this technology. First being around range and reliability. So the network's advantage really lies in its ability to cover large area due to the longer transmission range. So that's where that mesh type architecture comes in place, because essentially what it does, embedded into it is what I would call redundancies, right? Where these nodes acting as transceivers, it actually gives you multiple paths on how the data can be relayed back to the main hub. So it kind of essentially reduces the chances of a single point failure. Again, key here again being the frequency range. So it operates within the sub-gigahertz spectrum, and that offers better penetration through obstacles, and those can be bushes and the like, and longer range when you compare it, let's say, to 2.4 gigahertz frequency network, for instance. And the hopping mechanism just again allows for that scale, so that data transmission occurs by hopping through multiple nodes to reach the final destination, which is the main station. So for us, the hopping mechanism, that data can hop from device to device up to 5 times before it reaches final destination. So essentially each hop represents a transmission from one node to the other within the same network. And then we came with simplicity in mind, easy to deploy. And once you are setting up your network, you need just to press a button for 3 seconds, and then maybe give it a minute or so to join the system. That's all it takes to start logging water level data. So what you can measure with HOBOnet today. So I just saw here a question from Abdul asking if we measure soil moisture content. So today with HOBOnet, here is the new member of the family, the water level. But beyond that, actually, these are the other options we provide as part of the ecosystem. So anywhere from temp RH, all things related to weather data, your rainfall, wind speed and direction, solar radiation, leaf wetness, and we actually have a pretty expansive and various options when it comes to soil moisture. So we have multi-depth, and we have single point soil moisture, and even one that does EC and water and water potential. So we have quite a few options when it comes to soil moisture sensing. So again, I just thought it would be good to just, zoom back out and just make sure that I provide the right level of context when it came to the HOBOnet wireless sensor network. So now I'll transition to the deployment process. Again, I thought that rather than doing a demo, just stepping through what a deployment process may look like, things to think about would be helpful. So a couple things to consider just based on our experience and also experience shared with our users. Step one, I would say it is very important to do a site survey and do some level of planning, right? Conducting a thorough site survey to understand the terrain, potential obstacles, and required coverage is very important, because again, no two deployment are the same. We've had users that have had devices, I mean one device, right, communicating from each other from, to the distances of kilometers, right, 3 kilometers or 2 miles are some things we've seen. But also we've seen folks, just to be candid and transparent, even struggle to communicate within 500 meters, right? And but then you go look at the terrain, and it's just like, yes, there is, this mountain or this metal piece, and things like that, that's obstructing transmission range. So again, understanding the terrain, what you are faced with matters. I would say fundamentally, some of the key questions you're trying to answer there is, will you need repeaters? And by repeaters, they're kind of extenders. They allow you to just provide a redundant path for the data to go back to the station. For instance, this deployment that one of our users kindly shared with us, where you would see, these that almost looks like an A. It's like a tower. That's the icon we use for it. But those are repeaters. It just allows you to relay the information. So I would say site survey and planning, very critical, because all these will ultimately feed into your buying decision. This just sharing is an example. This is specific to ag, but it just to give you a view of what it would look like. This is one of our users. In the past, they were doing some field mapping. In this case, they cared about temperature mapping, but again, same technology, same transceivers, so it would apply for water level. So the area they were looking at was a 5 by 3 and 3/4 miles. So they did the evaluation and decided to go with 5 systems. So as you can see, it's a lot of sensors data that they were gathering, but based on the fact that they had rolling hills with elevations, and then you take into account, okay, how much ground can I cover with one system, and being sure they had kind of some, for lack of a better word, redundancy in the system to allow for that data to relay back. In this instance, they went with 5 dedicated systems to meet their needs. But in general, most customers will need 1 to 2 systems. A second tip or consideration is to set up your devices near the station, right? So because it does require you to we call it search mode. So there's a button you press on the station, get it in search mode, and then you press the button on the mode. And it is always easier to do it while they're all close together. If you already had a deployment already in place and you're just adding sensors to it, then I would just get the sensors close to the station. You do your setup, and if you haven't deployed them, you can literally do it, in your lab or in the back of your truck or your van when you're going to deploy, right? So you don't have to wait until you get in the field to kind of put the system together. You can do it prior to getting to the field, so that when you move the nodes around, then they will find each other and start connecting. Is the system connected to Ethernet, to the internet by LTE, satellite, Wi-Fi? What do I need to receive the data? That's a great point and great question. So the station is equipped with a 4G LTE module. So it essentially comes with the SIM. You can get a SIM from us, or you can buy your own SIM, and then you can access the data through our cloud-based software. That's a great question, Thomas. Third tip, again, consideration, again, all terrain being, again, different. I always recommend, having the station, if possible, depending on what your terrain looks like, at the highest point, because again, the station or the hub being such a critical element of your system, you really want it to be in the best location, because again, all the alerts, notification, data push, and all happen at the station level. Why did you stop manufacturing the Wi-Fi station? Great question, Curtis. It was just due to supply chain constraints. Just to be fully transparent, as a lot of companies were dealing with during the pandemic, we had some components that were no longer available. So we had to make some tough decisions on which areas we needed to invest to keep production going, and we needed to redesign part of the system. So we focused on getting the LTE system back up and running, and were forced to discontinue the Wi-Fi station. So here's an example, right? So this is a terrain, again, agricultural application. But as you would see, I believe this was a vineyard in Europe. You see rolling hills and all. So as you would see, what they've decided to do is, you can look at the side by side. They put the station at the top, provided some paths for the devices that were at the bottom of the hill to be able to come back up, and then they were all able to find their way back to the station. Another great question here: is the station also battery powered? Yes, it is, and they won the RX 2106 come with a solar panel already integrated with it, but the other station we refer to as the RX 3000, you can you just need to add a solar panel to it. And actually both stations as well, because our stations are pretty flexible. They also use in a lot of other applications. We also even provide a way to power it via AC. Beyond the station, the other thing I'll touch on is around node placement. So couple comments here. So we ship our products with a bracket that just allows for ease of deployment. So we highly recommend using that bracket to mount that node so that you can realize the expected performance of the sensor node. These are general tips. It's not always possible, but again, this is just to maximize range and what you are looking to accomplish. If possible, I would say, avoid metal poles because it does attenuate the transmission on one side of it, right? So let's say if you had a metal pole on the back side of the device, there won't be any issue communicating this way or left to right, but this way you couldn't communicate well, right? Because the metal pole will attenuate that signal. So in general, try to avoid metal poles again if you can. Here is the location of the antenna. This is courtesy of one of our users in South America. They even go above and beyond where they put the antenna above even this PVC pipe, just again to maximize range. So those are just little tips. So a question came earlier with line of sight. Without getting too much in depth on the technical side of things, in general, what I say about line of sight is just antenna, the antenna position, which is kind of at the moat, is kind of key, right? I like to say that height is definitely your friend here, because even though line of sight, is about the ability, to not have any obstacle between the nodes. One thing to keep in mind as well is what sometimes reduces transmission range is that the ground absorbs some of that signal, right? And that signal is reflected. So line of sight, generally, when we speak about line of sight, when it comes to wireless communication, generally refers to this thing that's called like the Fresnel zone. So essentially the transmission kind of, what's the right term? I'm fishing for the term. So I would say like the transmission zone, right, is almost like shaped as a football, or American football. So essentially what you're trying to do is this zone, you're trying to move up as far away from the ground as you can. And ultimately what helps you with that is height. So the higher the antennas are, the further your signal will go. So that's why earlier when I was sharing those specs about the transmission range, so that 450 meter transmission range means that those antennas are at a height of, I think, 1.8 meters, right? And you can get to that 600 meters when that antenna height is at 3 meters, I believe. And again, the higher it is, the further your transmission range will go. A couple other comments here. I may have to speed up here a bit around scalability consideration. So the data hops 5 times, right? But as I was mentioning earlier, part of wireless sensor technology is to make sure that there is some hopping mechanism and some redundancy. It can be tempting to kind of, to maximize range, to kind of have them all in series. But one thing to keep in mind, and there's nothing wrong with that, it will operate just fine. But a couple of things you want to avoid is, again, having too many devices just communicating through one node, because each node, again, acting as a transceiver, it uses power when it's receiving the data and uses power when it's transmitting it. So it can reduce the battery life. Not an issue at all if, let's say, you have enough sunlight, but in areas where you may not have enough sunlight, that could be an issue. But more importantly is, again, the stability of the system is only as strong as its weakest link. And this type of topology, if you have it flat and linear, what happens is, because life happens and wireless sensor technology can be finicky, is that, if something happened with this device that's kind of key to transmitting the data all the way back, is essentially, yes, these devices will keep logging the data and store the data, but that data cannot make it back to the main transmitter so that you can push the data to the cloud and have access to your data. So long way of saying, just try to avoid a single point of failure where possible. And also, again, always before deploying the network at scale, just conduct a small scale test, right, to validate your terrain and your environment. Look at the signal strength and reliability in the actual field conditions. A couple more. So here, and we also have our software where you can, it allows you remotely to check your node power, monitor the network connectivity. And again, you can always, use our map feature on our software to just detect potential single point of failure, right? Once the system settles and you see the data path, how it's going, sometimes you may say, well, I may either add a repeater or move a sensor just to make sure that I don't have a single failure point. So a little bit more kind of, those tips were kind of general to the wireless sensor technology in general. But now being a little bit more specific on the water level sensor itself. I'll separate these between the hardware and the software. Starting with the hardware, with folks that are familiar with our HOBOnet wireless sensors, we generally ship them with the sensor already connected. So this will be our first product due to its nature, where we need it to be flexible so that our users and customers can select the right cable length. So this is the first one that will ship it without the sensor attached. So one key thing that's important, and again, all these things that I'm going to be stepping through are in the quick start guide in our documentation. So you don't have to remember them, but I just wanted to provide few info. So it is important that you make sure that, the sensor, the cable, and this interface connector are attached before you start adding this device to the network. If you add a device to the network for the first time without that sensor, it may generate errors, right? Because what happens is that the device joins the sensor. The sensor joins the system, and what the system first tries to do is detect and say, like, who am I talking to? Like, who are you, right? And then at that point, without the sensor attached, it doesn't know what device is talking to, and that could create errors. But if it happens again, it is something that can be easily fixed. It is just a power up sequence error. And all you would need to do is, again, just make sure, again, the sensor is connected, the cable is connected on the top end. You just remove your batteries, remove the batteries out of the device, essentially power cycle them, right? Like with all electronic devices, sometimes if they're giving you a hard time, it's always good just to remove batteries and plug it back. And that will actually reboot the system, and it will join just fine. But post any type of, I guess I'll call it power up or joint procedures, any unintentional removal of the sensor, or let's say you were using a 4-meter depth sensor, you get in the field and you realize, oh, I should have used a 9-meter depth sensor. At that point, you can just swap the sensors. You don't need to go back through the whole kind of bring up sequence. That will just take care of it. Another thing is, again, this mode we are shipping it, again, the device on the top end comes with this 1.8 meter cable, right? So this cable is meant as a means to communicate between the direct read side and the mode side. So this should not bear any weight. It should not be used to suspend your water level sensor. And again, we ship it with a toe tag, so you'll see it. And again, all of this is documented. What we recommend is, when you're suspending your direct read, is actually to use that long cable and route it like so, as an example, right? You just route the direct read cable through the post, and it will provide you the right level of strain relief that you need. And also in our documentation, we provide other options and recommendations where you can even have it all kind of this dongle comes with a post where if you wanted to deploy it inside the well where you could do it. But ultimately, the transceiver has to always be outside for obvious reasons. And this is just an example, courtesy of Andrew, one of our team members. Again, nice setup where you're routing using the direct read to route it in the well. Then you use some type of T-post at the bottom to secure your PVC, and then you just route the cable, right? And then just enough heights, as much height as possible, just again to expand your communication range. As you can see here, you have trees, bushes, and the likes, and it still goes fine. It transmits. This is another example, courtesy of one of our end user, Paul. So here, as you can see, good height. Again, same thing, using a PVC. I think, yeah, I believe he's also using a T-post, if I'm not mistaken. Also have a PVC pipe that he slotted so that he could run the cable inside that pipe, again, just to protect that cable against animals and the like. So again, another nice setup, good height, and getting a lot, as you can see, good line of sight, clear, and getting maximum range there. On the software side, a couple of things I wanted to touch on. So for folks who are familiar with HOBOlink, so this is just a quick view of HOBOlink. I just thought I'd take a quick screenshot. So again, to the question earlier, how do you access the data? So we have our cloud-based software, HOBOlink.com.coms, where you can get the data. So once your mode joins the system, you automatically will have access again to the 4 parameters: water level, differential pressure, water temperature, barometric pressure, and then we give you some information on the last time the data was pushed, connectivity, and things like that. Regarding the water level or the water depth, as I mentioned earlier, you can use it to set a reference water level or account for water pressure. Sorry, water density. So I figure I just give a couple examples. So what we are doing, we have this scaling feature in HOBOlink, which essentially allow you to add a multiplier and an offset. So we're leveraging that multiplier, right, to be able to set your water density. Fresh water would be one, so it doesn't impact. But let's say if it's brackish water or salt water, you may want to use a different offset. So it is ultimately optional, but just for higher accuracy. I'm sorry, that multiplier, accounting for water density is optional. It's not something you have to do, but for higher accuracy, you want to account for water density. And then this offset will allow you to set for the reference water level. So again, just giving a couple examples. So for fresh water, it would be 1, brackish water, 0.99, salt water, 0.9765. When it comes to reference water level, there are few options. Let's say in an application where you are using your reference point at the top of a well, then your reference, you want to view your reference water as a negative value. If you are referencing it, if the reference water level is kind of, the reference point is below the sensor, then it's a positive value. And then if all you care about the sensor depth, you don't have to do anything from that standpoint. So I'll just give a quick example. These are the steps you want to follow when calculating that offset value to account for reference water level. Again, you don't have to remember all of this, but I just figure it's important to walk through it. So some of the steps is that, if you plan to account for water density in your deployment, you want to make sure first you enter that multiplier value in HOBOlink before you record that initial water depth reading. So if you don't do it initially and then you decide to enter a water density value that's different from 1, you will have to correct kind of those initial value, because that multiplier will change that value, right? Then you want to record, your initial reference water level or static reading, and then you calculate that offset. So I'll just kind of walk you through an example where you're deploying a water sensor in a well. You're initially taking your static reading, and then you have an initial reading of the sensor depth. So here's an example. So let's say this is an example where your static reading is 6 meters. So from the top of the well to the top of the water is 6 meters. That's your static reading. And then the sensor depth, that initial sensor depth is, let's call it 2 meters, right? Where you haven't accounted for the well, let's say it's 2 meters. There are going to be two options, right? One option would be when you're first taking the static reading, you've already accounted for the water density, right? So you've already entered the water density, saved that setting, and then you take an initial reading. And that initial reading reports back 2 meters. So at that point, to set up your offset, all you would need to do is, I guess it's adding, but it's more like subtracting, right? Because you want to take that initial static water level reading, which is -6. Again, it's below the reference point, so you want to look at it as a negative value, and then you subtract the 2, right? So from the sensor to the top, it will be the 6, and you add the 2, it's 8. So that offset comes out as -8, so that when in the equation it does 2 -8, it gives you -6. Kind of a bit funky, but that's the best way I can explain it. But let's assume now that when you were taking your static reading, right, this -6 static reading, you had not entered the water density, and you decide to enter the water density afterwards. So if you had taken an initial reading of 2 at the beginning, let's say that initial reading, that initial water depth was 2 meters, your static water level reading was 6, but then when you go to enter your offset, you're just like, oh, it was more of a saltwater application, so I want to adjust my water density just to be sure that I have a more accurate reading. So at that point, when you're calculating the offset, which is going to be a constant throughout the deployment, you want to correct for this 2, your initial reading of 2. So at that point, you would have to correct that initial reading of 2. So by multiplying it with the water density that you've decided to add, and at that point, it will be 1.953, right? And then you do the same calculation, -6 minus this value, then it gives you a slightly different value, which will just ensure accuracy. Flying through it, hopefully not confusing, but again, all of this is documented in our quick start guide and our software to help you walk through it. So this is just, again, in a situation where you are you want to have a way to reference that depth value you're reading, so you can make sense out of it. This is one manual step, I guess I'll call it, that would be required. But beyond this manual step, from this point on, there isn't any other calculations or manual or anything manual that's required. So more about HOBOlink. Again, that's our cloud-based software. That's where you'll be, viewing your data, customizing dashboards, setting up your alerts, setting up your exports that you can schedule, and then and again, all is you'll get your data as already corrected because already barometric is already compensated. And if you would like to ingest our data into a third-party platform or your own software platform, we also have API you can use to do that. And you can also, you can actually, as you set up your dashboard, you can also set up a public URL that you can share with others where they don't have any right access, or they can edit any of your settings. All they can do is just view the data. So if you're in a enterprise type environment, it is pretty neat to be able to share the data while being confident that no one is gonna touch it. So actually a little bit over my 45 minutes. So I'll just try to wrap up your next 3 minutes so I can make sure I can go through your question. So applications so far where we've seen success with this product is in the stream and wetland restoration market, with mitigation bankers really seeing great success in that area. Other applications where we've seen early adoption is around, agricultural monitoring, mining, water management, fish farming, watershed, stormwater management, and dam management. So they're being used in streams, again, in large farm fields, and again, and being also used by municipalities when it comes to wetland restoration. So pretty flexible product. So I guess some closing thoughts or final points that I wanted to make, things we see as a benefit is around the efficiency and the ease of use. Again, this may be a new product, but the sensor itself is a sensor that we've had around for maybe now close to 10 years. So it is a reliable, proven sensor technology. Again, any area where you want to measure multiple points within a specific area, if you have multiple wells or multiple streams you want to monitor, it really optimizes your operations by consolidating some of your monitoring effort. Again, comprehensive coverage, battery power, convenience, near real-time insight, and more importantly, just the proactive alerts that you get so that you actually know what's happening. With that, I know I flew through this, but I just wanted to make sure I get a minute to go through your questions. Oh, sorry about that. All right, great. Give me just 1 second to orient myself here, and I'll go through the questions. All right, some I've already touched on, so I have lots of great questions, so please bear with me. And if I don't get a chance to get through your question, we'll be sure to follow up after the webinar. So one question from Thomas: I have a SCADA system in place. Can I integrate HOBO in my network? You mentioned API. So what we allow right now is cloud-to-cloud API. So you can ingest our data into your cloud solution, but we don't allow direct access to our hardware. I hope I'm answering your question. Monitoring sea level, particularly in regard to climate change, is of many different locally and just must be a great point, David. Is there a fee for using API? No specific fees for the API, but we do have fees that are, we have one single fee, an annual fee, to be able to push the data to our cloud. So we have few options depending on if you are using our SIM cards or if you are using your own SIM and the amount of data you are pushing. So just to put some cost to it, roughly, I think it goes anywhere from $100 on the low end to 300 or maybe 350. Please don't hold me to it. We have all that data on our website, but it's an annual fee. Does any of the HOBO devices require recalibration at any point in their lifespan? These water level sensors themselves, they do not require recalibration. We may have other devices that do, more on the water quality side, but not these water level sensors. They do not. We need to monitor at different point at the same time. Sorry, yeah. We need to monitor water level in different depth pond at the same point in time. Is that possible? So yes, so when you set it up as the devices, two things you'll select. You'll select how often you want to log the data and how often you want to push it to the cloud. So for all the wireless sensors that are part of a specific system, they will log data at the same time. So I think there's a little bit of drift, but I think those drifts is in the seconds within a month, right? So yeah, so you can measure at the same time. Any plans to add a non-attached temperature sensor to the product line? Curtis, that's a great question. I'll take that on and I'll talk to the wider product management team to see what our plans are. I don't believe we have any plans on that right this time, but I'll take it as an NPR, a new product request. Any real-time water quality sensors available? Not at this point in time, Trace-on, but we are actively working on. Does trickle charging have switch off when you switch to lithium batteries? So Sean, yes. So the switch is so if you open the device, there's actually a small cable when you open the door that connects, the solar panel to the circuitry. So all you would have to do is unplug that cable. You would just have to unplug it. All right. How well do the sensors work in very remote area? I mean, the sensor itself is not an issue. When it comes to remote areas, the only things to keep in mind is, again, the main station is equipped with a 4G, with a LTE module. So do you have access to cellular? But as far as the sensors themselves, the devices, yeah, they are made to work in remote areas. If the water you are measuring is subject to freezing, will one of the transducers you displayed earlier work better than another? From a temperature standpoint, they're all frankly the same. They operate the same. It is more around, are you deploying the device in fresh water versus salt water? So that's really kind of, it is more about, kind of the water environment and the water depth. Gregory, that's where kind of which one you choose may come in play. But generally on the freezing part, I don't believe so. I don't believe it matters if you're using the stainless steel versus the titanium. but just to be sure, I'll reach out to one of our subject matter expert with the from the mechanical team and follow up with you, Gregory. Thank you, Abdul. Yeah, definitely the RX 2106, once you order RX 2106, the smart sensors you already are using are compatible with the RX 2106. And I apologize if I miss your questions. There are just quite a bit of them, but I'll be sure to follow up. Darby, what is the signal generated from the units? Is it a 420 milliamp? And can it be easily converted to a 900 megahertz for a SCADA system? Again, unfortunately, the hardware is not open to SCADA, but for now, we don't have a solution yet. There's something that we're working on around being able to accept analog inputs into some of our wireless sensors so that you can use third-party sensors. So that's to come hopefully very soon. But for now, all you can do is from a cloud-to-cloud API to ingest that data. You cannot access that data directly from the hardware. Are you using a 900 megahertz mesh radio? So we are in the 900 range. So Michael, for your question, so we have today 4 options. We have the 800, we have 868 that we use, I believe, for Europe, 900 in North America, and we have 921 and 922. So we are in the 900 range, not the 400 range. Will you stop supporting the current Wi-Fi system? Yes, Elijah. For now, yeah. At this point in time, there's all the Wi-Fi and Ethernet system that are out there are support this solution, right? So our plan is to continue supporting all the Wi-Fi and Ethernet systems that are out there. How often do sensors need to be cleaned, if at all? I would say it depends, Darby, as far as how often you need. I would say in general, most of our customers, generally to access because of data retrieval, would go about 4 times a year to their site. So it was a combo of data retrieval and at the same time you do maintenance, but without the need to do the data retrieval. I would say twice a year, but again it will depend on just the environment. If it's a relatively clean environment and you have it in a stilling well, as you're deploying it, then it is you need less less maintenance is required. So it would just depend on how you've deployed it. How many properties have this system so far? Kristen, I don't have a number that I can give you, but I can tell you that we have hundreds of these devices already deployed since we released it, and we just recently released it. And we're talking about some very large system. I mean, some of our big major customers have adopted it and seeing the benefits of it. But I'll make sure that we follow up on that, Kristen, to give you an answer. Is there a possible packet collision? This was quite common in mesh technology. No, Thomas. I mean, like all kind of wireless type deployment. I mean, yeah. I mean, you never want to be like in an airport or anything like that, right? Which isn't the case here. But no, all these products, they went through rigorous compliance certification. So all these products are compliant, so to perform without interference in all the regions that I showed earlier where we are compliant. So yeah, so some of those packet collision issues, none that I'm aware of, Thomas. does the price you showed earlier include 4 sensors? No, it actually only includes one sensor. I apologize if I gave that perception. So those 4 sensors are the options. So you would select one of those sensors as your depth. So it's essentially the node, the cable length, and one sensor to make, because only one sensor can plug to that node. So I apologize. So that view could have sent the wrong message, but I just wanted to show there the options we have. I see that Steve has left. Can these log data internally? Yes, they all come with memory. They all have the memory. They all have memory associated. So it logs the data, and then when it's time to push the data, it pushes it. And for whatever reason it cannot communicate with another sensor, it will store that data locally. Can you share the presentation? We have a stewardship group that meets once a week and have used some of your product. Keith, yeah, I'll check on that with our team. At a minimum, for sure, the recording will be available, but I will talk with our marketing team to see if it's possible to make the presentation available. If it's an option, then we'll be sure to get it to you, Keith. Well, we are out of time here, and I want to be mindful and respectful of everyone's time. I truly appreciate everyone joining us today. Thank you very much for your time. If there are questions that I failed to answer, I'll be sure to go through all of them, and we'll be sure to answer them and follow up. And again, before you go, please share your feedback. Your feedback is very valuable to us, and let us know if you would like us to follow up with you. So again, thank you very much for choosing to spend this time with us. Your presence here means a lot to Onset, and I truly appreciate it. So be well and take care. Bye-bye.